If you ever need to run a task every 5 minutes or send a keep alive ping after 10 seconds of inactivity, your first instinct might be Java util timer. Stop right there. Timer has issues. If one task throws an exception, the whole timer dies. It also doesn't play well with multiple threads. Instead, we have scheduled thread pool executor. It's like a normal executor but with calendar. This is how we can create scheduled thread pool executor. We can run task once after 10 seconds of delay, or we can run the task every 2 seconds after initial 5 seconds of delay. We have already gone through the constructor parameters and scheduler methods in previous video. I would highly recommend you to watch that. Now in this video, we will understand how does this scheduling actually work under the hood. It uses something called as DelayQueue. Imagine a DelayQueue as a special conveyor belt. You put an object on it, but you tell the belt this box cannot be picked up for 10 seconds. The belt sorts the box by the timer they expire. The box that needs to be picked up the soonest is always at the front. The scheduled thread pool executor has a worker thread that just does this. Look at the front of the delay queue. If the task's delay has expired, take it, run it. If task is recurring, calculate the next delay and put it back on the belt. If you ever need to build your own scheduler, maybe for a job queue, you don't need to reinvent the wheel. Just use delay queue wrapped with a thread pool. It's one of the most underrated classes in Java. As you can see here in a lead code discuss section, tech giants like Uber, LinkedIn, Rubrik frequently ask candidates to design scheduled thread pool executor because it is an all-in-one test of senior level engineering skills. Unlike a standard algorithmic problem, this question evaluates your ability to build a complex production ready system that handles real world constraints. So let's try to build our own custom scheduled thread pool executor. This is our custom scheduler that mimics scheduled thread pool executor from Executor framework. A delay queue is a backbone of scheduling. It holds tasks ordered by their delay. Tasks only come out when their time has arrived. We use an executor service to manage worker threads. These threads will continuously pool the delay queue and execute tasks. So here's how we construct the object. We initialize a fixed size thread pool. We pass a thread factory. With each thread has a name scheduler worker. An atomic integer ensures unique thread name safely in concurrent environment. We start the worker threads, and for each worker we submit dispatch loop. So let's see what this dispatch loop does. This loop continuously pulls tasks from delay queue and executes them. This loop runs forever until thread is interrupted. DelayQueue.take method blocks until a task's delay has arrived. Once task is ready, it is executed. If task is periodic, we reschedule it by updating its next trigger time and putting it back into the queue. Now, here we have these three famous methods from schedule executor service. First is schedule method, a one-time task after a given delay. So we create a scheduled task with one-time delay and put it in delay queue. Next is schedule at fixed rate, scheduling a repeating task at a fixed rate. First run after initial delay, then every period. So again, we create a scheduled task by providing initial delay and the fixed interval and put it on a delay queue. The third is schedule with fixed delay, which, which waits until task finishes. Once task finished, it then applies the delay before starting the next run. Notice here we take the period but we are inverting the sign. This is to distinguish between fixed rate and fixed delay task. At the end, this is how we shut down our executor. Stops all worker threads immediately, ensures no further tasks are executed. And here we have the most important static in our class, which represents scheduled task. It implements both runnable, so it can run, and delayed, so it can stay inside delay queue interfaces. Here we store the task, its period. If period is greater than 0, that means it's fixed rate task. If it is less than 0, then that means it's fixed delay task. If it is equal to 0, that means it's not periodic. And trigger time, the next execution time in nanoseconds. So our first constructor is one time task, runs after initial delay. The second task is a periodic task which has initial delay and the period. The trigger time is calculated as the current time plus the delay. The gate delay method from delayed interface tells the queue how much time remains before the task is ready. So we subtract the next trigger time with the current time. Compare to method ensures tasks are ordered by their delay. So we compare the delay between two tasks. The run method actually executes the task. Each periodic method checks if the task is repetitive. And here is the rescheduling logic, which updates the next trigger time for periodic task. Before going to the logic, let's understand fixed rate tasks and fixed delay task. So fixed rate task, let's say if it starts at 9 with 10 minutes of initial delay, the first run at 9.10 and then subsequent runs will happen at 9:20, 9:30 and 9:40. For fixed delay, if the first run happens at 9:10 after 10 minutes of initial delay and first run takes 9.30, the next run will happen after 10 minutes, that means at 9:40. So this is how fixed rate and fixed delay tasks work. So let's come back to the rescheduling logic. So if period is greater than 0, that means the task is fixed rate task. So the next run is previous trigger time plus the given period. And if period is less than 0, that means the task is fixed delayed task. Then the next run will happen the current execution time plus the given delay. Here we are subtracting the period because for the fixed delay we are taking period as negative. And this is how we can use this custom schedule executor. We create a scheduler with two worker threads. This is how we can run one-time task which runs after 2 seconds, fixed rate task which runs every 3 seconds after initial delay of 1 second, and this is how we run fixed delay task which waits for 2 seconds after completion before next run. I have intentionally put main thread on sleep for 12 seconds so that you can see this happening in the logs, and then we shut it down. Let me run this code. So you can see our fixed delay task started, then another thread picked fixed rate task, then we got one time task got executed, then fixed delay, then fixed rate. This is how the execution happened, and after 12 seconds of sleep the main thread shut down this scheduler. Try running this code yourself. You will see that the two worker threads process these periodic or delayed tasks and the queue handles the overflow. It's a great way to really understand what's going on. If you found this video helpful, please give it a thumbs up and subscribe for more technical content.